AWS Content Delivery Network and Services provides a range of services that helps business to deliver the content and data to their customers in a fast, secure, and reliable manner. This helps users around the world to view the same high quality content without slow loading times. Without a CDN, content origin server must respond to every single request. This results in significant traffic for the origin server and subsequent load. Thereby, that increases the chances of origin server failure if the traffic spikes are extremely high. Content delivery network and services solves this problem for the users. Once you host the application on the cloud, you would want the users get the better performance when they access the application. The goal of the CDN is to reduce the latency by reducing the physical distance that the user's request has to travel. CDN store a cached version of your website content in multiple geographical locations around the world, which are known as point of presence. These point of presence will contain their own caching servers and will be responsible for delivering that content in the user's location. Content and delivery services enable the customers to distribute and deliver the content and applications globally. The content and network delivery services include the multiple components like Amazon CloudFront. CloudFront securely delivers data, video, application, and APIs to customers with low latency and high transfer speed. Amazon Route 53. Route 53 is a highly available and scalable DNS service that translates the domain name to IP addresses. S3 Transfer Acceleration. S3 Transfer Acceleration is a data transfer service that uses CloudFronts as a location to accelerate the data transfer over the internet to Amazon S3. The transfer acceleration can be used if you are transferring large amount of data to S3 over internet. Direct Connect, a dedicated network connection from on-prem data center to AWS that enable customers to transfer large amount of data with low latency and high throughput. Global Accelerator, a service that routes the traffic to nearest AWS region for faster delivery of applications to end users. Elastic Load Balancing, automatically distribute the incoming application traffic across multiple EC2 instances, containers, and IP addresses in one or more availability zones. These services work together to provide a solution for delivering and distributing the content and applications globally. Let's talk about each of these services in detail. Next, let's talk about AWS CloudFront. CloudFront is a content delivery network service offered by AWS. A content delivery network or CDN is a network of servers that are distributed around the world and are used to store and deliver the content to users based on their geographic locations. When a user requests the content, CloudFront routes the request to the server that is closest to the user, ensuring that the content is delivered quickly and with minimum latency. CloudFront works by caching the content at different locations known as locations around the world. When a user requests the content, CloudFront checks to see if the content is already available in the cache at the nearest as location. If the content is available, then the as location serve the content directly to the user. If the content is not available at the nearest as location, CloudFront retrieve the content from the origin server, such as Amazon S3 bucket or an EC2 instance, and store a copy of the content at the nearest as location in the cache memory for the future purpose. CloudFront can deliver both static and dynamic content. CloudFront provides advanced security features such as DDoS protection. CloudFront integrates with AWS Shield, a service that provides the DDoS protection for your content. Web Application Firewall or AWS WAF. Web Application Firewall integration. CloudFront can be integrated with AWS WAF, which allow you to create the rules to block the malicious traffic and protect your web applications from the common web exploits. CloudFront provides several benefits. Low latency. By routing the request to the nearest as location, CloudFront ensures that the content is delivered to users with minimal latency. High transfer speed. CloudFront uses a global network of servers to deliver the content, which can improve the transfer speed compared to delivering the content from a single location. CloudFront supports SSL and TLS encryption to protect the data in transit between the client and the origin server. Integration with other AWS services. CloudFront can be integrated with other AWS services such as Amazon S3, Amazon EC2, and Elastic Load Balancing. CloudFront offers a number of security features to protect the data and resources that are delivered through the services. Some of these security features include SSL and TLS encryption. CloudFront supports HTTPS and SSL TLS encryption to protect the transit data between the client and the origin server. Origin protection. CloudFront allow you to restrict the access to your origin server to only CloudFront IP addresses, which helps prevent the unauthorized access to your content. Custom SSL certificates. You can use your own SSL TLS certificate to secure the connections between CloudFront and your users. Signed URL and signed cookies. You can use the signed URL and signed cookies to restrict the access to specific content to only authorized users. DDoS protections. CloudFront integrate with AWS Shield. AWS Shield is a service that provides the DDoS protections for your content. Web application firewall integration. CloudFront can be integrated with AWS Web, which allow you to create the rules to block the malicious traffic and protect your web applications from the common web exploits. Geo restrictions. CloudFront also allow you to restrict the access to your content based on the geographic locations. Access logs. CloudFront can store the access logs in S3 bucket, which can be used to track and analyze the user's traffic. CloudFront is a great service that helps to improve the performance and security for your web applications. A practical use case for Amazon CloudFront would be a company that runs a content heavy website, such as a news or media website, that needs to deliver the large amount of data and multimedia content to users across the globe. The company could use the CloudFront to distribute their content across a global network of edge locations. When a user requests the content from the website, CloudFront route the request to the edge location that is closest to the user, which can help to reduce the time it takes to download the content. This improves the user experience, especially for users who are located far away from the origin server. The company could also use CloudFront to improve the security of their websites by using the features such as SSL TLS encryption to protect the data in transit. CloudFront can also be used to improve the performance of the website by caching the content at the edge locations. This means when a user requests the content that has already been requested by another user, CloudFront can serve the content from the edge location without having to retrieve it from the origin server. Company could use the CloudFront integration with other AWS services such as AWS WAF to protect the website from common web exploits and DDoS attack. Overall, CloudFront is a great solution to run the content heavy websites where we need to deliver the large amount of data and multimedia content to users while improving the performance and security of the website. Next, let's talk about AWS Global Accelerator. AWS Global Accelerator is a networking service that routes the traffic over the AWS network to improve the availability and the performance of your applications. AWS Global Accelerator is a networking service that sends the user's traffic through AWS Global Network Infrastructure. Improve your users' performance up to 60%. Global Accelerator utilizes the IP address and edge locations to route the traffic and uses the IP resolution instead of the DNS. So once the user reaches the edge location, no matter where you are resolving it to, it's going to route the traffic through AWS network and not the public internet. It can route the request to many different AWS resources, and that includes things like network load balancer, application load balancer, EC2 instances, or an elastic IP addresses. Now let's see how AWS Global Accelerator work. AWS Global Accelerator works by directing the traffic to the optimal AWS region. It does this by using the AWS Global Network, which is the network of point of presence located in various regions around the world. When a user requests to access an application, the request is first directed to the nearest AWS Global Accelerator endpoint. The endpoint then uses the AWS Global Network to determine the optimal AWS region for the user based on factors such as geographic locations, application health, and network congestion. Once the optimal AWS region is determined, the endpoint directs the user's traffic to that region. This can help to improve the application performance, reduce latency, and increase availability for users around the world. AWS Global Accelerator also provides static IP addresses called Accelerator IP that can act as a fixed entry point to the applications hosted in one or more AWS regions. Additionally, it also allows you to configure the health check for each endpoint, so it can automatically fail over to healthy endpoint in case of any issues. AWS Global Accelerator can be used to improve the availability and performance of variety of applications, including web applications, mobile app, and APIs. Now, you might be wondering what is the difference between CloudFront and Global Accelerator, as both are used to improve the application's performance. So let's talk about the difference between Global Accelerator and the CloudFront. AWS Global Accelerator and Amazon CloudFront, both services are offered by AWS, but they serve the different purposes. AWS Global Accelerator is a service that improves the availability and performance of the applications by routing the traffic to the optimal AWS region for a given user. It uses the AWS Global Network to direct the traffic to the optimal AWS region based on factors such as geographical locations, application health, and network congestions. It can improve the application performance, reduce latency, and increase the availability for users around the world. Amazon CloudFront is a content delivery network that speeds up the delivery of a static and dynamic web contents to user. It uses a global network of edge locations to cache the content and deliver it to the users from the edge locations that is closest to them. This can help to reduce the latency and improve the performance of web-based applications for users around the world. In summary, AWS Global Accelerator route the traffic to the optimal AWS region for a given user, while CloudFront speed up the delivery of the contents to the user. They both can be used to improve the application performance, reduce latency, and increase the availability, but are intended for different types of traffic and different use cases. Next, let's talk about Internet Gateway. AWS Internet Gateway provide a simple and secure way to allow the communication between instances in your VPC and the Internet. Internet Gateway is a horizontally scalable, redundant, and highly available VPC component. Internet Gateway serves as a bridge between your Amazon VPC and the Internet. It enables the communication between your instances and Internet. Internet gateway must be attached to a VPC in order to function. A VPC can only have one internet gateway attached at a time. The internet gateway is referenced in the VPC route table to allow the traffic to flow to and from the internet. Instances in a VPC with an internet gateway attached must have a public IP address in order to communicate with the internet. Internet gateway is a core component of any VPC architecture that requires the secure and reliable connectivity to the public internet. There are a few key points about Internet Gateway. Connectivity. Internet Gateway provides the connectivity between your VPC and the Internet. It enables the traffic to flow between public IP addresses assigned to your VPC and the public Internet. Scalability. AWS Internet Gateway is horizontally scaled, meaning it can handle a high volume of traffic and is designed to automatically scale as your network traffic increases. Redundancy. AWS Internet Gateway is redundant, which means if one gateway fails, another can take over without any disruption to your network traffic. Security. AWS Internet Gateway is stateful gateway, which means it tracks the state of the network connection between the VPC and the Internet. This allows it to enforce the security policies such as allow or block the traffic based on specific criteria. Configuration. You can configure your AWS Internet Gateway to route the traffic to specific destinations, such as other AWS services, on-prem resources, or internet. Cost. Internet Gateway pricing is based on the amount of data transferred over the gateway. There is no upfront cost, and you only pay for what you use. You can use the Internet Gateway to provide the internet services in your VPC. You can use the Internet Gateway with Net Instance or Net Gateway. That totally depend on your application architecture or business requirements. When you host the application on AWS, you will always want that your application is always available. Elastic Load Balancing is a service that automatically distributes the incoming web traffic across multiple EC2 instances to ensure that your application is always available and can handle a large number of requests. When a user requests to access your application, ELB or Elastic Load Balancing will automatically route the request to one of the available instances, ensuring that the load is distributed evenly and no single instance become overloaded. It also checks the health of the instance before distributing the load and automatically route the traffic away from the instances that is not healthy. There are two types of Elastic Load Balancer. Application Load Balancer. Application Load Balancer actually route the traffic based on HTTP and HTTPS. Network Load Balancer. Network Load Balancer routes the TCP and UDP traffic. Next, let's talk about the Application Load Balancer. Application Load Balancer automatically distributes the incoming web traffic across multiple EC2 instances. It routes the traffic based on HTTP and HTTPS. Application Load Balancer can route the incoming traffic based on the content of the request. This is accomplished by using the routing rules that match the URL path, host header, or other request attributes to a specific target group. This allows more fine-grained control over how traffic is distributed to your instances, making it possible to route the request to different parts of your application based on the URL path or other request attributes. Application Load Balancer allow you to offload SSL and TLS decryption from your instances and handle it at the load balancer. Application Load Balancer allow you to configure multiple listeners on different port and protocols. Next, let's talk about the Network Load Balancer. Unlike Application Load Balancer, which routes the traffic based on the content of the request, Network Load Balancer routes the traffic based on the IP protocol data. Network Load Balancer is used to route the TCP and UDP traffic to multiple EC2 instances, and it can handle millions of requests per second while maintaining the ultra low latencies. Network Load Balancer allow you to maintain the client connections to a specific instances, even if the instance become unavailable. Network load balancer allow you to configure multiple listeners on different ports and protocols. Network load balancer has the following benefits. High performance. Network load balancer is capable of handling the millions of requests per second while maintaining the low latency. Connection persistence. Network load balancer allow you to maintain the client connection to specific instances even if the instance become unavailable. Sticky sessions. Network load balancers allow you to maintain the client connections to specific instances even if the instance become unavailable. Health check. Network load balancer can check the health of the instances and automatically route the traffic away from any instance that are not healthy. Multiple listeners. Network load balancer allow you to configure multiple listeners on different ports and protocols. Scale horizontally. Network load balancer can automatically scale to handle large amount of traffic by distributing it across multiple instances. So you can choose any load balancing method. You can choose network load balancer or application load balancer based on your architecture or your application requirement. Next, let's talk about AWS Route 53. Route 53 is a domain name system service offered by AWS. It's a global service. That means any change that you make are applied globally. Route 53 leverages the AWS as locations. Route 53 is a DNS service offered by AWS. It's a global service. That means any changes that you make are applied globally. Route 53 offers several advanced features such as health check, failover, and latency based routing to ensure high availability and optimal performance of your applications. Route 53 integrates seamlessly with other AWS services such as S3, Elastic Load Balancing, and AWS Certificate Manager to provide a complete solution for your applications need. Route 53 provides a simple console to manage the DNS records, and it integrates seamlessly with other AWS services to provide a complete solution for your applications need. AWS Route 53 offers these several benefits compared to the traditional DNS system. Scalability. Route 53 is designed to handle millions of requests per second and can scale automatically to handle the traffic spikes and DDoS attacks. Route 53 is a globally distributed service with multiple points of presence that ensure the reliable and fast routing of applications. Performance. Route 53 offers advanced routing policies that enable you to route the traffic to the nearest AWS regions, minimize the latency, and improve the end user's experience. Route 53 offers pay as you go pricing with no upfront cost or minimal fees, and you only pay for what you use. Amazon Route 53 is a highly available, scalable, and cost effective DNS service that can help you to route the traffic to your applications. Route 53 provides a complete solution for your DNS needs with advanced features such as health check, failover, and latency based routing. Scaling on AWS refers to the process of increasing or decreasing the resources such as EC2 or RDS instances. Scaling is one of the key services that helps you to handle the virtually unlimited load and request on your cloud hosted applications. Scaling automatically increase or decrease the resources as and when required for your application performance. There are two main types of scaling on AWS. Vertical scaling. This type of scaling involves increasing or decreasing the size of a single resource, such as increasing the amount of memory or CPU of an EC2 instance. This is also known as scaling up or scaling down. Horizontal scaling. This type of scaling involves the adding or removing the resources, such as adding or removing the EC2 instance to increase or decrease the capacity. This is also known as scaling out or scaling in. There are multiple services on AWS that helps you to scale the resources as and when required for your application performance. Auto scaling. Auto scaling automatically increase or decrease the number of resources based on predefined policies. Elastic load balancing. Elastic load balancing automatically distribute the incoming traffic across multiple resources to ensure that no single resource become overloaded. Vision CloudWatch. CloudWatch monitor the resource utilization and automatically trigger the scaling actions based on the predefined policies. Elastic Beanstalk. Elastic Beanstalk is a platform as a service that automatically handles the scaling and deployment of the applications. AWS Lambda. Lambda automatically scales to handle the incoming request. You can use any of these scaling services on AWS to handle the unlimited load for your cloud hosted applications. The scaling service you will use depend on your application architecture and business requirement. Next, let's talk about the security groups. Security groups are like virtual firewall that control the incoming and outgoing network traffic to an EC2 instance. AWS security groups are like stateful firewall, meaning once a connection is established, the response traffic is automatically allowed, regardless of any rules. Security groups have separate inbound and outbound rules that define the traffic that is allowed to flow into and out of an instance. Rules can be specified for specific IP addresses, range of IP addresses, or the security group, and the rules can be based on protocols such as TCP, UDP, or ICMP and on port numbers. Every EC2 instance is automatically associated with the default security group. It's recommended to create a custom security group with more restrictive rules. An EC2 instance can be associated with multiple security groups, allow you to apply multiple set of rules to the same instance. Security group rules can be modified at any time, allow you to change the level of access to your instances as needed. AWS also provide tools and services for auditing and logging the security group activity, such as Amazon CloudWatch logs and CloudTrails. Let's talk about virtual private cloud. AWS Virtual Private Cloud provides an isolated and secure network environment for your applications and data in the cloud. Virtual private cloud is one of the core components to host the applications on the AWS environment. Amazon Virtual Private Cloud is a service that allow you to create a virtual network in the AWS cloud. VPC support both IPv4 and IPv6 address types. With VPC, you can launch your own EC2 instances in a virtual network. You can assign your custom IP ranges to your network and configure the security and access control on your VPC. VPC allow you to customize your network settings such as IP address range, subnet, route table, network gateways. VPC allow you to create a secure, isolated environment within AWS cloud and still allow you to access the internet and other resources within the cloud environment. VPC allow both private and public subnets. So if you want to have some applications that can't communicate or can't be reached over the internet, or if you want to have some applications that are accessible from the internet, you can do both. If you have servers in private subnet that need internet access, you can use the network address translation or NAT function for those private subnets. And there are multiple ways that you can actually establish a connection to your data center. You can create the multiple VPCs and connect the VPCs to each other with pairing connections, or you can use the transit gateway to enable the communication between multiple VPCs. There are multiple core components in a VPC that helps you to create the private network in the AWS cloud. Subnets. VPC is divided into one or more subnets. You can launch the resources such as EC2 instances into a subnet. Network address translation. VPC enables the instances in a private subnet to connect to the internet or other AWS services using NAT services. Security group. A security group acts as a virtual firewall for your instance to control the inbound and outbound traffic. Internet gateway. An internet gateway is a VPC component that allows the communication between instances in your VPC and the internet. Virtual private network. A VPN connection or a virtual private network can be established between your VPC and your data center that allow you to secure the communication between the two networks. Elastic IP addresses. An elastic IP address is a static IP address designed for dynamic cloud computing. You can assign the same elastic IP address to an instance in case of an instance failure. VPC peering. VPC peering enable you to connect two VPCs together to allow the communication between instances in the connected VPCs. VPC flow logs enable you to capture the information about the IP traffic going to and from your VPCs. We will talk about these core components in more detail in the coming slides. So first, let's talk about subnet. A subnet is a range of IP addresses within a VPC that allow you to group the instances based on security and operational requirement. The subnet must be associated with a VPC. You can associate a subnet with a single VPC, but a VPC can have multiple subnets. Subnets are of two types: private subnet. Private subnet can't communicate to the internet. Public subnet. Public subnet can communicate to the internet. A subnet can be associated with a route table, which controls the traffic routing for the subnet. You can create the subnet in one or more availability zones, providing high availability and failover capabilities of the applications hosted within that subnet. Next, let's talk about virtual private network. Virtual private network or VPN service allow you to connect your on-prem network to your Amazon VPC over an IPsec VPN connection. This allow you to securely access the resources in your VPC as if they were on your local network, providing a secure and reliable connection between your on-prem network and your VPC. VPN services uses the IPsec protocol to securely connect your on-prem network to your virtual private network in the cloud and has two core components. Virtual Private Gateway. Virtual Private Gateway is created in your VPC and serves as the target of your VPN connection. The VPC acts as a bridge between your VPC and your on-prem network. Customer Gateway. Customer Gateway is created on your on-prem network and is the source of the VPN connection. The customer gateway from on-prem establishes the IPsec VPN connection to the virtual private gateway in the AWS cloud and form the IPsec VPN connection to provide the secure connectivity. Once you establish the IPsec VPN connection, then you can enable the routing. You can update your VPC route table to allow the traffic to flow between your on-prem network and your VPC over the VPN connection. Scalability. You can create the multiple VPN connection to your VPC to provide the redundancy and increase the overall capacity of your VPN connection. IPsec VPN is the most common method to provide the secure connectivity between on-prem and AWS cloud. Next, let's talk about network address translation. Network address translation or NAT is used to enable the instances in a private subnet to connect to the internet or other AWS services. There are two types of NAT services offered by AWS. NAT gateway. NAT gateway allow the instances in a private subnet to access the internet hosted applications or other AWS services. While you cannot initiate the connection for those instances from the internet, NAT gateway is a highly available and managed network address translation service. AWS NAT Gateway is a fully managed service that automatically scales to handle the large amount of traffic that makes it suitable for use in an environment with high level of traffic. NAT instance. A NAT instance is a virtual machine in a public subnet of a Amazon VPC that allow the instances in a private subnet to access the internet while preventing the internet from initiating a connection with those instances. A NAT instance is a virtual machine in a public subnet of a Amazon VPC that allow the instances in a private subnet to access the internet or other AWS hosted applications. The NAT instance act as a proxy for outbound internet traffic from instances in the private subnet. When an instance in the private subnet send a request to access the internet, the request is forwarded to the NAT instance, which then send the request to the internet on behalf of the instance. When the response is received, the NAT instance forward it back to the requesting instance in the private subnet. NAT gateway and NAT instance both allow the applications hosted in the AWS private subnet to access the internet and internet hosted applications. But there are certain differences between NAT gateway and NAT instances. So let's talk about that. Management. NAT gateway is a fully managed service provided by AWS, while a NAT instance is a virtual machine that is managed by yourself. Scalability. NAT gateway automatically scale to handle the large amount of traffic, while a NAT instance can become a bottleneck as the traffic increases. NAT gateway provides better performance than a NAT instance due to its ability to automatically scale. Monitoring and logging. NAT gateway provides monitoring and logging through Amazon CloudWatch metrics and CloudTrail logs, while a NAT instance require a manual setup and configuration. High availability. NAT gateway provide automatic failover in the event of an instance or a availability zone failure, while a NAT instance require a manual failover setup and configuration. Cost. NAT gateway has a predictable and low hourly cost, while the cost of a NAT instance depend on the instance size and uses. Now in this module, we will talk about different storage services offered by AWS. Amazon Web Service offer multiple file storage services such as Amazon S3. It's a highly scalable, secure, and durable object storage service that allow you to store and retrieve the data from anywhere on the web. It is designed to store and retrieve any amount of data from anywhere on the web. Amazon EFS or Elastic File System. It is fully managed, highly scalable, and elastic file storage service that provides shared file storage for Amazon EC2 instances. It is designed to support a wide range of workload and applications, including big data analytics, media processing, and content management. Amazon FSx. It's a fully managed file storage service that provide highly scalable file systems that are accessible over the SMB and Lustre protocol. It is designed to support a wide range of workloads and applications, including Windows-based application, high-performance computing, and machine learning. Amazon Storage Gateway. It is a hybrid storage service that enable you to securely store and retrieve data from AWS cloud storage and to connect your on-prem applications with the AWS cloud. It provides a virtual tape library, file gateway, and volume gateway to support a wide range of storage scenarios. Each of these file storage service offers unique features and benefits and can be used for a wide range of workloads and applications. We will talk about these services in detail. Next, let's talk about S3 or Simple Storage Service. Simple Storage Service is a cloud-based object storage service provided by AWS. It allows the users to store and retrieve the data in the form of objects. First, let's understand what is object storage. Object storage is a type of data storage architecture that manages the data as object instead of a block or files. In object storage, each object consists of a data, metadata, and unique identifier. The data can be of any type such as documents, images, videos, or audio files. The unique identifier is used to locate and retrieve the object from the storage system. Object storage is highly scalable and designed to handle massive amount of unstructured data. Object storage in Amazon S3 is a type of data storage that store data as individual object rather than as a file hierarchy or block device. Each object is identified by a unique key and can contain data, metadata, and various access control information. The objects are stored in a flat namespace, meaning that there are no hierarchical relationship between objects, unlike traditional file system. Object storage in S3 is designed to scale horizontally, meaning that it can store an effectively unlimited amount of data by adding more storage nodes to a cluster. This makes it a well suited for storing large amount of unstructured data such as photos, videos, and backup. Object storage system also typically provide features such as versioning, which allow the users to store multiple versions of an object and roll back to a previous version if necessary. S3 provides a simple web service interface that can be used to store and retrieve any amount of data at any time from anywhere on the web. S3 stores the data redundantly across multiple devices in multiple facilities. S3 is highly durable and reliable storage solution for a wide range of use cases, including backup and archival, big data analytics, and disaster recovery. Amazon S3 at a high level lets you store files as object inside of a bucket. Now, bucket are the unit of the organization within S3. You will create a bucket. It will have a set of settings, and then any file that you drop in the bucket can have those settings applied to it. It allows you to store the data automatically across multiple availability zones, which give you the durability and resiliency for your data. Now, another great feature of S3 is that it enables you to have URL access of your files. So if you want to send a link to someone else to access the file within your S3, assuming the permissions are correct, you can actually do that. And it also offers the configurable rule for data lifecycle. So if you want something to expire after a period of time or go to some different storage class, you can do that. It can also serve as a static web host, and we will actually be implementing that later within this module. When you store a object in S3, you can choose the different storage options based on your data accessibility and application architecture. So first of all, we have S3 standard, and by default, if you upload a file to S3, it will have the S3 standard storage class. Then we have the S3 intelligent tiering. And this is the special storage class that will allow you to move your data to a correct storage class based on uses. Then we have S3 standard infrequent access. So if you have data that is not frequently accessed, you can get a lower cost by utilizing this particular storage class. Now it still has the standard resiliency because it leverages the multiple availability zone. But we also have S3 one zone infrequent access, and this is for data that is not frequently accessed, but it is only stored within one availability zone. So you get a much lower cost with this storage class compared to other options. However, you do have a less resiliency. Glacier for long-term archival data that may be retrieved in several hours or even days. Glacier Deep Archive for the lowest cost archival storage with retrieval times of 12 hours or more. Let's talk about these S3 storage classes in more detail. So let's talk about the intelligent tiering first. Intelligent tiering is the only way that you can automatically move the data to the most cost effective storage tier based on access. It has two access tiers. Frequent access tier, this tier store the object that are frequently accessed. Infrequent access tier, this tier store the object that are infrequently accessed. The storage class automatically move the object between the two access tiers based on the access patterns and charges a low per object monitoring and automation fee. This makes it a cost effective for data with unknown or changing access pattern. This storage class is useful for customers with data that has unknown or changing access patterns and need a cost effective storage solution. The data stored in intelligent tiering storage class can be retrieved quickly and easily, and it can be transitioned to other S3 storage classes in the future if required. Next, let's talk about the S3 lifecycle policies. Amazon S3 lifecycle policies are used to automatically move the objects between different storage classes or to archive or delete the objects. Lifecycle policies consist of a set of rules that are applied to an object in a specific S3 bucket. Each rule has an action and a transition or an expiration date. For example, a rule might transition a object to the Amazon S3 standard infrequent access storage class 30 days after they are created, and then archive them to Amazon S3 Glacier storage class after 90 days. You can use the lifecycle policies to transition objects to different storage classes. For example, moving data from S3 standard storage to S3 infrequent storage after 30 days. archive the objects to Amazon Glacier S3. For example, moving data that has not been accessed for 60 days to Amazon S3 Glacier. Permanently delete objects, for example, deleting data that hasn't been accessed for 1 year. You can also set up different rules for different prefixes or object tags so that you can target specific groups of objects within a bucket. You can also create multiple policies for a single bucket, allow you to set different rules for different subset of objects. Lifecycle policies can help you save money on storage cost by automatically moving the data to lower storage class, and can also help you comply with the data retention and archival regulations by automatically deleting or archiving data after a certain period of time. Next, let's talk about the AWS S3 transfer acceleration. S3 transfer acceleration works by routing the traffic over Amazon's optimized network path, and it does it by utilizing the AWS as locations as part of the Amazon CloudFront, which minimizes the distance data need to travel over the internet. This reduces the latency and increases the transfer speed, especially for users who are located far away from the S3 bucket. To use the S3 transfer acceleration, you simply need to enable it on the S3 bucket that you want to use it for. You can then use a special endpoint provided by AWS to upload or download the data from the bucket. It works by using the CloudFront as locations as acceleration endpoint that can upload or download the data to and from the Amazon S3 at a faster speed than a direct connection to the S3 service. This can be particularly useful for users who need to transfer the large file over long distances, such as between different regions or continents. It is worth noting that S3 transfer acceleration may not be beneficial for all use cases. For example, if you are transferring data within the same AWS region over a high speed private network, you may not see any significant speed improvement. However, if you are transferring the data over long distances over the public internet, S3 transfer acceleration can be a useful tool to improve the data transfer speed.